Okay, a lovely extension task then, using the sine rule to do some side chasing. We're asked to find the length of CD. If I was going to use Pythagoras to find that, I would need to know this side here and this side here. Unfortunately, I've got neither at this stage. If I was going to use trigonometry, I need to know one, or I need to know the other one of those two, and then I could do it. I'm not sure at this stage if I've got enough information to find this. I could find it, but I'd end up probably finding the length of CD first anyway. So that's not going to be any use to me in helping me actually find CD. Let's go with this one. And the reason why I think it's that one that is going to be useful to us is because it's part of another triangle already. And that suggests to me that there's probably some information in that other triangle that's going to be useful. So what I always do if I've got a problem like this is to draw out a second version of it so that I can work on it and not worry about messing up the original diagram. Let's get rid of you. There we go. So that's what we're working on, and there's a straight line there which is quite useful to us. Label it with what information you've been given. So that's C, that's B, that's A, so we can all talk about the same points. And then the angles that we've got are 40 degrees and 47 degrees, and the length here is 50 meters. If we're going to use sine, the sine rule, which I suspect we're going to want to use to find this length here, CB, then we would really want to know a pair of a side and opposite angle and another pair and its opposite angle. Let's say we've got a pair. Well, the good news is the matching pair to that one, the one that we're trying to find, is already down here. So we've got that. That's a good sign. So we could fill that in already. We could write A over sine 40 equals, and this is the tricky bit, we don't have another pair. I can see that this side is 50, so I'd probably really like to know this angle up here. So I could put 50 up here, and now I need to know what the angle is up there. What is the angle? Well, this angle here is on a straight line with this angle here. So that we can find by doing 180 take away 47, and we get 133. So that angle there is 133. If that there is 133, when I add it excuse me, to 40 and subtract from 180, then I'll find out what angle C is. So 180 take away 133 plus 40 is going to be 180 take away 173, which is 7 degrees. So this is 7 degrees up here. So sine of 7 degrees there. And if I rearrange that, then I'll get that A is equal to 50 times the sine of 40 all over sine 7. And if I put that into the calculator, I would get, clear that, 50 sine 40 close brackets divided by sine 7. I could do that as a fraction, close brackets. But I get 263 meters. Well, 264 rounded to the nearest whole. So I should write 263.7 meters. I'll keep it to one decimal place for now. Okay, that's good. That's useful. That's 263.7. And now I could use that angle with that side. They make a pair. And I could use 263 opposite this angle here, which is obviously 90. Well, it's not obvious, but in the question, the bit that I didn't show you is that it's up against a brick wall. This is a brick wall sitting on a floor, so we'll assume that that's at 90 degrees. And then if I was to use the sine rule, I would treat this as A and this is big A, and I would make this big B and this little b. So A over sine 47 equals, what does it equal? 263.7 divided by sine 90. And now rearrange that and you get A equals 263.7 times sine 47 all over sine 90. And let's put that into the calculator. So you get brackets answer times sine 47 close brackets divided by sine 90 close brackets equals 192.9. So A equals 192.9 meters to 1 decimal place. Okay, thanks for watching. Bye.